Yeah, what was the last topic we discussed when we met last 2 weeks? Can you hear me? Hello? Hello?
Hello, sir.
Yeah, I'm asking a question. Tell me where we ended last time we met. I want to know so that I'll continue from there. Okay, since I'm not getting response from as we have covered up to uh, reviews and inspections, so I'll take it from there. All right, so I'm going to take it from here. I'll move faster because we are behind time. We have to cover a lot of things today so that we can um, actually finish what we are supposed to learn during the semester. So we have learned in quality management, software quality management, that there are attributes that you want to achieve or you want to see in the system that is developed. And those are the quality attributes. So you can think about maintainability, um, reliability, portability, usability, and all that. Okay, so once you are thinking about those things in terms of the quality of the software, you have to put certain practices in place so that whatever you are developing is actually meeting the requirement in terms of the quality that you want. So if you want to have something that you want to, or you have to practice to achieve um, the quality you want in a software. So we are looking at reviews and inspections. Now, at the beginning of the semester, I explained that errors are accumulated in the system that is being built from whatever you have designed. So at every stage of the it's important that we put in place certain measures, practices that will help us detect and remove the errors before the system is deployed. So that is all we want to look at today. Who as processes or system and it
Yeah, please, your line is bad.
the various product requirement specification documents. We can also talk about the designs. We can talk about the code. We can talk about the test plan and the test cases. we can also talk about the documentation itself. All these things can be classified as products or artifacts. So what we'll do is that the team will look at the various artifacts and see if there will be some potential problems or errors in them. So that is what the group would. The artifacts and they are satisfied that everything is fine, they will have to give the development team go ahead. In other words, they will have to sign off so that they can move to the next stage of the system that they are developing, right? So that is what the sign off means. It means that the team doing the review will have to sign off or give approval to the development team to move to the next stage of the system development. All right, so for them to be able to do work in terms of the review, they need to have objectives. So here we want to look at some of the objectives. And in that case, they are looking at the product. The last one has and this group will carefully examine
Sir, please, your line is bad.
we have different types of attributes. Sorry, different types of artifacts. I can see your hands up, but let me finish explaining what I'm doing. Then I can give you the opportunity to ask questions. So the group will look at the various artifacts. It could be all of them or some of them. That is what I mean by part or all. So let's say the group is interested in just the design. That means that they are going to focus on the design and try to find if there are potential problems in the design. Okay, so now you can ask your question, or if it's a comment here.
Okay, so it's about your line. It's very breaking. It's not stable at all.
Hello, can you hear me?
Yes, I can hear you now, but it's not stable. It breaks along the line. Hello.
Yeah, Emmanuel.
Yes, yes. I was saying your line is not stable. It breaks.
Yeah,
Uh,
a good signal. So even as I'm lecturing now, I'm not in my home. I have better signal, but still you can see that it's not very stable. So now, so the to be able to see if there are errors in there. So doing that, they may look at the code, they may look at the designs, they may look at the specifications.
sir, is that bad
What
though? We can hardly comprehend with what you are saying, sir.
because the signal there is I don't have control over the signal. MTN. Oh, yeah. Can you hear me now? Hello?
Yes, is
Yeah, we can hear
clear
you.
now.
We can hear you. Okay. All right. So as I said, the problem is that after the flood, we started having issues with the network in our area. And I think it's a general problem. So so the software, once they are done with the review, they will have to sign off. And the sign off here, as I explained, means that they are okay with whatever they have said in the artifact, and they want to go ahead to the team, the development, to continue to the next stage of the development, system development. So basically, that is what the sign off means. And so the review is actually done in phases. So you can see that we have 3 phases here. The first one is the pre-review activities. The first one is the pre-review activities. And the second one is the review meeting. And then we have the post-review activities. During the pre-review activities, the team will prepare. So there's a planning and there's a preparation during the pre-review phase of the review process. And once they are done with the planning and preparation, they now go into the meeting. That is the second phase. So during the review meeting, the development team will walk through the document with the review team. And once they do that, the review team will try to spot or find issues or problems that are in the artifacts that are being viewed. And so any issue or problem that is detected will be discussed during the review meeting. And so after the review meeting, then they go into the post-review phase where the issues that have been identified during the review meeting will be addressed. So basically, this is how the review is done using the three phases that we have seen here. So in a pictorial form, we can look at it and say, if you look at it diagram or sketch, you see that we have the various phases that I've mentioned. So we have the pre-review activities, we have the post-review, and then the review meeting itself. As I said, the pre-review activities are the planning and group preparation. And then during the review, there's individual preparation before the review meeting. And after the meeting, there is post-review activities. And the activities will be error correction, improvements to the artifact or the work that has been done. And then there's a follow-up. Okay, so now the scenario that I've presented to you in terms of the review process is that of face-to-face meeting. Okay, so the scenario looks like face-to-face meeting to discuss the various artifacts and the documents that have been produced by the development team. But it's also true that these days, because of the technology we have, we can also do review remotely. That means that the documents, the artifacts will have to be shared before the meeting starts. So they will go through the artifacts, they will go through the products, the documents, and then if there are issues in the document or the artifacts, then they will be discussed during the review meeting. That will be done online, remotely. So that is that about review and distributed reviews. How about inspections? Here, or the engineer will examine the source of the system. And the aim is to discover defects and anomalies. Okay, I can see the network is unstable here. Let me pause. Yeah, so the inspection is just like review. It's done by the team to discover defects and anomalies. Inspections is not done by executing a system. In other words, if you're going to do inspection, you don't have to run the system to be able to see if there are defects or errors in there. You can actually look at the physical representation of the system or the representation of the system and be able to discover defects or errors. Because of that, you can actually do inspection when we are looking at the requirements, the design, the configuration data, the test data, and all that. Because you don't have to run the system to be able to do inspection. That also means that even before the system is implemented in terms of programming, you can still do inspection. Okay, so that is one good thing about inspection. And it has been shown to be very effective when it comes to discovering errors in a program. So to do inspection, you will need a checklist. Yeah, that the network is not stable. You need a checklist to do inspections. So what are checklists? Checklists basically will contain common errors. And these errors normally are errors that you want to find in the system. So these errors will be documented. And then during the inspections, you check the system against the common errors that have been listed in the checklist. So error checklists are programming language dependent. What that means is that every programming language will have its own specific or characteristics error that are likely to be in the program that has been developed. So depending on the programming language that is used, you have your specific checklist, and then you use that checklist for the inspection. So in general, the weaker the type checking, the larger the checklist. Example will be others that of faults in the checklist, and that will help you. So example is the data output fault, and the type of inspection you're supposed to carry out are all listed here. You have storage faults, exception management, storage management faults. To assure quality in a system that is being developed. And fits or is that of what we can call a plant-based approach to system development, where inspections can be done and the review can be done. How about agile development? We all know that when it comes to agile development, they have their own style or approach to system development, which talks about flexibility, talks about quick delivery, and developing a system in iterations. Okay, so how do they approach reviews and inspections whilst they are developing a system using agile methods? That is all we want to look at now. Okay, so quality management in agile development is informal rather than document-based. Why? Because we know that agile guys or agile team does not focus too much on documentation. They are more interested in producing a working system quickly, and so they don't spend time on bureaucratic stuff like documentation, detailed documentation. Okay, so because of that, when it comes to review, they will rather want to have what they call quality culture. So quality culture is what they use to assure quality in their system development. So what is a culture? Culture, basically, we can describe it to be how things are done in a particular setting or environment or community. How it's done in a particular setting or community or environment. Then that is a culture. Now, applying that to system development, we can say that the way the development team goes about their system development is their culture. Okay, so when we talk about quality in terms of quality culture, in terms of system development, what we're trying to say is that there should be some practices or quality practices that will be part and parcel of the things they do in terms of to develop a system. Okay, so they want to introduce certain practices that will help them achieve the quality that they want in the system they are building. So that is what we're looking at, we're describing as quality culture. Here, when they're talking about quality culture, they expect every team member to be responsible for the quality of the things that they do in terms of the system development. Okay, so they try to avoid bureaucratic overheads like standards-based approaches, and then the quality processes like ISO 9001 that we have discussed or will be discussing. Okay, so what are some of the practices that will help them achieve quality in the work they do? The Agile guys have shared good practice. The first one says you should check before you check in. What that means is that if you're working on a part of the system, and before you add it to the whole system or existing one, you need to check it before you do that. Let me explain that quickly. Now, we know that Agile guys work in incremental fashion. They develop system in incremental fashion. In other words, part of the features are implemented and then tested and for them to see that it's working. Once that is working, they go into the next iteration and then they develop additional features and add it to the existing one. So that is what we mean by incremental development. Now, so let's say that they have built a system that is working. Let's look at this system as a system that has been developed using few features and is working. This is done during the first iteration. So during the second iteration, they will build another system. Let's look at it as this one. And they will take it. If it's working, then they will integrate it with the second one. The integration is according to the plan, and it's like adding it to the existing ones. So the quality culture is saying that check before you check in. In other words, check this one, the current one that you have developed now, check it, test it, and make sure that it's working fine before you add it to the existing one. Okay, so that is what it means to say a build. In other words, by adding, make sure that when you add the new features that have been developed to the existing system, make sure that by adding it, you have not destroyed or you have not broken the existing system. So that is the idea of never break the build. So the team members should not check in code that will cause the system to fail. In other words, by adding these features that have been developed to the existing system, make sure it doesn't cause the existing system to fail. So developers have to test their code changes against the whole system and be confident that this works as expected. Now, there's something called regression testing. Anytime new features are developed and added to existing system, you need to test the whole system to be sure that it's working fine. Okay, so that is known as regression testing. So regression testing is done repeatedly as and when new features are developed and added to existing system. So agile guys say never break the build. Make sure by adding these features, you don't cause the whole system to fail. Then the third one here says fix problems when you see them. Now, the idea they're trying to say or express here is that, you know, in agile, you have teams, smaller teams working on different tasks. Okay, and at the end of the day, they bring their work together to have a complete project. So they're trying to say that, let's say you have a different team working on a different task, and then later maybe you spot a problem or you find a fault or defect in what you are doing. Once you find it, fix it. You don't have to wait for the people or the team that has worked on it to come and then fix it. You are part of the group. You are part of the development team. Once you spot a problem, fix it. Don't wait for the one who did it to come and fix it. So that is what the third one is saying. Fix problems when you see them. Okay, so let's continue to the next slide and see what is there. So reviews and agile methods. Now, the review process in agile software development is usually informal, as I've explained, because they don't go by detailed documentation. However, agile guys have their own style of carrying out their review. And it also depends on the methodology that you are using. For example, in a method called Scrum, there is a review meeting after each iteration. Okay, so we all know what iteration is. It's a phase in the system development where few features are developed, tested, and then they go into the next iteration. So we're saying that after there is a review meeting after each iteration. That means that after implementing few features, they have a meeting, and that meeting is a review meeting. They have that meeting before they go into the next iterations. And during that meeting, whatever issues that they've encountered, it could be about the system that they are working on, it could be about the process or whatever. They will discuss it and then find solution to them before they move on or they go into the next iteration. So that is how they approach their quality assurance or review in terms of quality assurance. Then in another method that we call extreme programming, in extreme programming, they have what they call pair programming as a quality assurance practice. So the pair programming says that you should have two people working together. For example, if you're going to write a code, at a desk, you have two people sitting at a desk. One will be writing the code, whilst the other person will be doing the review. Okay, so we can describe it as what we know as a driver and a mate. So whilst the driver is writing the code, the mate will be doing the review. So they do that for some time, and then they switch roles. So the mate will become the driver, and the driver will become the mate. So that is done during pair programming, so that they are able to quickly spot errors or defects in whatever they are doing and correct it before it is delivered. So that is what is done during pair programming. So as I've explained, you can see the text on pair programming. This is an approach where two people are responsible for code development and work together to achieve this. Code is developed by an individual and is therefore constantly being examined and reviewed by another team member. So pair programming leads to a deep knowledge of the program, as both programmers have to understand the program in detail to continue development. The depth of knowledge is difficult to achieve in inspection process, and one is writing the code, another is doing the you are able to then resolve them before you move on. And those are these in pair programming. The pair, the two guys working in a team may not understand the specification or requirements of the system. And they do is that to implement it and not properly developed. That both members of a pair may make the same mistake. Discussions may, because they understand the assets, they are so implemented. The second one, do pair repetition. The pairs may be reluctant to look for errors because they do not want to slow down the progress of the project. That is the second issue. Now, what is the issue here? The issue is that we know when we're working on a project, we have deadlines to meet. Okay, so you are working fast, you want to meet deadlines, and then you also have to be doing review, trying to resolve issues that are spotted in the code. Sometimes it can slow you down. And so we're saying that, or we're learning that whilst the pair are working in terms of writing code and doing review, they may decide not to pay too much attention to the quality side by doing review because they are thinking about meeting deadline. Okay, so that is what the second one is saying. The third one has to do with working relationships. Sometimes when you become familiar with the team member, I mean, the team members become familiar, they become friends. And so that will also influence the work they do. So the one doing the review may not even want to criticize the team member he or she is working with. Okay, so that will mean that they will overlook some of the things that, or the mistakes that they are supposed to correct. Because of the working relationship they have, they may overlook some of the issues. So these are some of the weaknesses we can actually find when it comes to pair programming. So agile quality management and large systems. What are the challenges when it comes to quality assurance in agile? Okay, so for agile, we know that it's appropriate for developing smaller systems that do not require detailed documentation, systems that they can quickly develop and release. Okay, so they are very good at that. However, when they have to work on systems that are large and it will take them a long time to finish, I'm talking about complex projects, they have issues. The issues are as a result of not doing detailed documentation. And so because they don't want to spend time doing detailed documentation, when it comes to large systems, they have issues. So basically, that is the idea when we're looking at agile quality management and large systems. And also, where there are several geographically distributed teams involved in the development, perhaps from different companies, this informal communication may be impractical. That is to say that agile guys don't practice formal communication. They believe in, like I described, having review meeting. Most often it's like a stand. They stand and then they have a short meeting, discuss their issues, and they go back to their desk. This kind of meetings is not appropriate when you have the teams geographically distributed. In other words, the teams are scattered in different locations working remotely. It will be difficult to have this kind of stand-up meetings after every iteration. Okay, so that is another issue when it comes to working on large systems using agile approaches. Okay, so if you go through, you understand what I'm trying to say here. Everything here has been explained in terms of agile. Now, the last topic in this slide has to do with software measurement. Now, how do we measure software? The measurement is concerned with deriving a numeric value for attributes or a software product process. All right, let me explain something here. When we talk about quality, we looking at two things. As I explained earlier, we're looking at the product and we also look at the process. We know that the product is developed using the process. And I explained that if you want quality products, then the process should be a quality one. Okay, so that means that there's a relationship between the product and the process. I remember I used a diagram to explain how we can use the product quality to standardize a process and then use that process to develop subsequent products because we believe that has been the standard. Now, so when it comes to measuring, we want to have values for the various attributes. And this will allow for objective comparison between techniques, in other words, the methods and the processes that we're using to develop a system. There are a few established standards in this area when it comes to quality in software development. So software to measure. Let me explain what I mean by metrics. Now, if you go to measure something to have units, that will allow you to think about the false index, number of persons per. Okay, so once you have these ideas as metrics, it allows you to quantify the work that you're doing. Okay, so it allows the software and the software process to be quantified. And maybe it may be used to predict product or to control the software process. All right, and also the product metrics can be used for general predictions and to identify anomalous components. So there are types. When it comes to metrics, we have types of process metrics. And these are listed here. The time taken for a particular process to be completed, the resources required for a particular process, the number of occurrence of a particular event. And so you can see from this diagram, we have predictor and control measurements. So basically, we're looking at how to measure the process and the products for the quality attributes that are used to, that we want to achieve in the software. And that is all this part of the slide is discussing. Now, what I want us to do is, there are some topics that we need to treat in order to understand this diagram. That I want to quickly start discussing those topics. Actually, it's in testing. So when we are done with that, then I'll come back to this part. Hello. Hello. This. Okay. Can you see the slides?
Yes.
It's software testing.
Yes, sir.
Okay. So this is the second slide I'll be sharing with you. The first one that we discussed was on quality management, and this one is software testing. We have other ones that one is on software reliability engineering, and then we also have evolution, software evolution. So you see, we have more things to discuss. Now, so I'm taking testing. I pray I'll be able to finish today so that we can discuss other things next week. So in these slides, we have what we call development testing. We have test-driven development. We have release testing and then user testing. Okay, so program testing. Why do we have to test system? And how do we approach it? Now, when you want to test a system, okay, first let me explain the reason we test a system. So testing is intended to show that a program does what it's intended to do and to discover program defects before it is put into use. Now, if you read these first statements, you realize that the purpose for testing has been stated here. And if you look at it critically, you realize that there are two main reasons or aim for testing a system. The first one is that you want to show that the system is doing what it's supposed to do, what it's intended to do. So you test it to show that it is doing what it's intended to do. Then the second one is that you test a system in order to discover the defects in that system. You discover the defects in the system. You test it to discover defects. That is the second purpose. Now, so how do we test a system? When you test a system, you execute a program using artificial data. For example, let's say that this is a system, okay? We can look at it as a black box. The black box means that we don't care about what is inside. All we want to see is that it's doing what is intended to do. So assuming we are told that this is a calculator, it can do addition. Hello, assuming we are told that this can do addition, then we want to test it to see if it's really a system that can do addition. So we'll give it inputs, data, and then we'll observe the output to see the behavior of the system by seeing if output is correct or not. So let's say this is a calculator that can do addition. We'll give it 2 plus 2. And we all know that 2 plus 2 is supposed to be 4, right? So if we observe the output and the output is 4, then our conclusion will be that this system is doing what it's intended to do. Okay. However, if let's say instead of 4, the output is 6, then we can see that this system is not doing what it's intended to do. In other words, it's giving us the wrong output, which is the 6. All right, so these are the two scenarios or two cases you can have if you are testing a system. So we're saying that when you test a system, you run the system or you execute the system, give it inputs, which is artificial data. You have your test data, give it to the system, then you observe the output, and then you come up with your conclusion if that system is actually doing what it's intended to do or not. So you check the results of the test run for errors, anomalies, information about the program's non-functional attributes. Now, when you test it this way, the test can reveal the presence of errors. For example, if you add 2 to 2 in this system, getting 6, then it's revealing the presence of error because 6 is not supposed to be the result, but it's telling us it's 6. That tells you that there's an error in the program. However, if you are getting 4, which is correct answer, you are tempted to say that there are no errors in the system, but that cannot be the case. If we test it and we get correct results, it does not mean that there are no errors in the system. Okay, even though you are getting the correct result, which is 4, you can't conclude that there are no errors in the system. That is what is written here. That if you perform this test, it can reveal the presence of errors. Yes, in the case of 6, it can reveal the presence of errors. However, if you get in 4, this system cannot show that there are absent. Okay, so that is what the second part is saying. So testing is part of a more general verification and validation. Okay, so you remember few minutes ago, we're discussing reviews and inspections. When it comes to quality assurance, there are different approaches that we can use. Some of them are static approaches. Static. And then we also have dynamic approaches. We have dynamic approaches. Now, what is the difference between static and dynamic? Static basically means that we are not going to run the system, or we are not going to execute the system before performing the kind of test that we want to do. Okay. But dynamic, you have to run the system, you have to execute it in order to observe the output, and give it input, observe the output, and be able to have your opinion about the system. All right, so if we look at this two, we can say that reviews and inspections are part of our static techniques. Review and inspections are static techniques. And then testing is dynamic technique. Okay? Why is testing dynamic? It's dynamic because when we're performing testing, we have to run the system, give it inputs, and observe the output to see if the system is behaving well. In other words, if the system is giving it the correct output. So it's a dynamic process. However, if you're performing reviews and inspections, you don't need to run the system. As I explained earlier, you don't need to run the system to be able to discover defects and errors in the system. So reviews and inspections are static techniques, and testing is a dynamic technique. Now, all these things can be classified as verification and validation. All right, so that is why here we're saying that testing is a part of a more general verification and validation process, which also includes static validation techniques. So when we talk about static validation techniques, we look at reviews and inspections. When we're talking about dynamic, then we look verification and validation, then we're talking about testing. Okay, so that's what I wanted. With explanation. Okay, so explained already that we have aims for testing a system, and we saw from the previous discussion that basically there are two goals. Has been specified for it. Okay, so we test to demonstrate to the developer and the customer that the software meets its specification. Desirable or does not conform to specification. So this second part is where we want to find defects in the system by testing it. So if you're going to do the first one, you want to test to show that the system is doing what it's intended to do or is meeting the requirement, then you have to perform validation tests. You have to validate the system to show that it's actually doing what it's supposed to do. However, if you want you want to show that the system is actually doing what it's intended to do. Then, if you want to show there are defects in the system, you will perform defect testing. That is what has been explained. The second goal leads to defect testing. The first goal will lead to validation testing. So testing process goals. The goals, one is validation testing and second, defect testing. As I explained, the validation testing is to demonstrate to the developer and the system customer that the software meets its requirement. So in that case, for you to say that the test is successful, then the test has to show that the system is actually conforming to its specification or is doing what it's intended to do. Then you can actually say the test is successful. In the case of defect testing, our goal is to show that there are defects in the system. So we can only say that defect testing is successful if we have actually, or the test actually exposed the defects, the errors in the system. Then we can say the defect testing or the defect test is a successful one. Okay. Hello, can you hear me? Are you there?
Yes, sir.
Yes, sir.
Any question or comments so far? Any question or comments?
No, sir.
Okay. So because we have two main goals for testing a system, to show that the system is doing what it's intended to do using validation testing, and second, to show that the defect in the system using defect testing. It also means that when we are going to choose the data, test data, to perform the test, we also have to get two classes of test data. Okay. And the first one will be the one that will show that the system is doing, actually producing what it's supposed to produce, meeting the requirement. And the second kind of test data will be the one that will cause the system to misbehave or to expose the defect in the system. So that is what we are seeing here. So if you look at input class and you also have output class, and the system is at the middle. So for validation testing, we'll use the first one, which is the input test data, and then we use it to test the system and you observe the output. So we have the output test results. Okay, so that is validation testing. If we performing defect testing, we're going to choose input types that will cause the system to misbehave. In other words, expose the defects in the system. So we'll choose the input that will cause anomalous behavior. Okay, that will be the second class of inputs. The input that will cause anomalous behavior, and we use it to test the system. And then the outputs that will observe will reveal the presence of defect in the system. So generally speaking, we'll have two categories of inputs, one for validation testing, and then the other one for defect testing. So now let's discuss verification and validation. These are two terms that are similar, but they are not the same. Okay. So in terms of system development, looking at the products and the process. How do we explain these two terms, verification and validation? Okay, so for us to understand these two terms in system development, we need to ask ourselves two different questions. The first one has to do with verification. So for verification, we want to ask ourselves, are we building the products right? Okay, are we building the products? Then for validation, we want to ask, are we building the right products? So if you look at these two questions, for verification, the question is actually looking at addressing the process that is used to build the product. So it's asking, are we building the product right? In other words, the process that we're using, are we using the right approach? Are we using the right processes to build the product? Are we building it right? Okay, so that means that the software should conform to its specification. However, if you are looking at validation, you say, are we building the right product? So you see that the focus is on the product. So what it means is that if you are looking at validation, the software should do what the user actually requires from the system that is being developed. The software should do what the user really requires. All right, so another way of you can look at these two terms is during the process of developing a system, you want to verify that you are doing the right, you are building the right product. Okay, you are building the product right. Okay, you want to verify that you are building the product right during the process. Then, once you're done with the verification, you want to be sure that you are done with the product. You want to be sure that the product is actually the right product by validating it. So you validate it to be sure that it's the right product. So this is how we can look at these two terms in terms of system development. Okay, one talking about the process and the other one's looking at the product. So why should we be interested in verification and validation? Why should we verify that we're building the right product, we're building the product right, and also validate that we have built or we are building the right product? Because we are looking at quality, okay? We are looking at quality assurance. And so the aim of the verification and validation process is to establish that, or the confidence that the system is actually fit for purpose. Now, you will have to implement. But if you want to achieve all the quality attributes in your system, you end up compromising on some of those attributes. So to make life easy for us, we rather want to focus on, okay. So to make life easy for us, we rather want to focus on fitness for purpose. That is, we want to focus on the quality requirements that are really needed in the system that you are building. And that is what we mean by fitness for purpose. So if you develop a system that is supposed to be maybe supposed to play music and it's able to play the music, then you are saying that it's fit for purpose. Now, so we use V&V to establish the confidence that the system is fit for purpose. And to be fit for purpose depends on the purpose of the system. Okay, what is the purpose of that system? You need to know the purpose and also know the user's expectation. What are the expectations of the users? And also the marketing environment. So the purpose you need to know, and that's the level of confidence depends on how critical the software is to an organization. And the user's expectation, users may have low expectation of certain kinds of software and may also have high expectations. So you need to know the expectation of users. You need to know the purpose of the software. Then also the marketing environment. The environment here has to do with how people respond to different kinds of products. How do they want it? Okay. That will also guide you whether the system is fit for purpose. So if you consider these three factors, then using V&V, you'll be able to establish that confidence that the system is fit for purpose. So that is why we have to verify and then it's the products. So inspections and testing, we have discussed inspections already. In quality assurance, quality management, we discuss inspections and the testing. So here we want to compare testing and testing with inspections. So as I said earlier, software inspections is concerned with analysis of the static system representation to discover problems. So as I said, it's kind of static verification technique. So we can say inspection is a static verification technique. How about testing? Software testing is a dynamic verification, because here we have to run the system, or the system is executed using test data and its operational behavior is observed. So it's a dynamic process. That is why we are describing testing as dynamic verification. So looking at this diagram, we can actually understand how we can apply inspections and testing to quality assurance. Okay, so that diagrams of artifact database, and we have system prototype. Now, if you look at this artifact, you see that there's an arrow coming from inspection. And we also have arrows coming from testing, pointing at program and inspection. System prototype. Now, what are we learning from this diagram? Can apply inspections to all of these artifacts, because we don't need to run them. You need to execute it. You need to run it, give it input, observe output. And we know that it's not possible to run requirements and the system prototype. We can only and the system prototype. That is why we have the arrow from testing pointing at only the program and the system prototype. Is there any question about this one? Hello? Hello?
Hi.
Hello, sir.
Yeah. Yeah, are you following the discussion?
Yes, yeah, following.
Okay, do you have any question or comment?
Not at the moment.
So yes, you can see that we can test the prototype. We can also test the program, but we can't test the requirement specification. We can't test the software architecture. We can't test the UML design models. We can also not test the database schemas. However, we can inspect all of those ones in addition. So software inspections we learned earlier involve people examining representation. And aim is to discover anomalies or defects. The inspections do not require execution of a system. I explained that already. And so it may be used before implementation. What that means is that once you start from planning, specification, design, you perform inspections. Okay. Then before you start writing the code, you can to the analysis before you even do the coding. Once you are done with the coding, you can still do it. It's written before you start doing inspection. No. Since there are other artifacts that do not require the system to be executed, you can have access to them even before a code is written. That is what the second one saying. Maybe apply to any representation of the system like requirement, the design configuration, test data, blah, blah, blah. They have been shown for discovering program also. So some of the advantages of inspections. It is good that and discover if you run the system. Do inspection, you to discover some errors. Can decide area testing because it's not error asking or hiding. If you had a problem, some should work because they know that it's a system with problem with test. Okay, it's not getting those be harmful. But if I special, I can call the system. So that is one about inspections. It can also be done on incomplete version of a system. But if you want to test an incomplete system, you need to have a special kit to be able to do that. So basically, those are the things we want to look at. So considering this thing, somebody will say that, okay, this and testing, inspections and testing are complementary and not open verification techniques. So both should be used during the BMV process. Inspections can check conformance with the specification, but not conformance with the customer rel requirement. Inspection cannot check non-functional characteristics such as performance, usability, etc. Now, what is the point here? Some people will be tempted to say that, okay, as for me, I will test the system. I'm not going to do inspections. Another person will say, no, I will do inspection. I'm not going to test that system. There will be a problem. What is the problem? Because I just explained that there are some types of errors, defects, that if you use testing, you'll be able to discover. And there are some that you can discover using inspections, which you can't discover if you use testing. So that means that if you want to get optimal results in terms of the quality that you want, then you need to use both dynamic and static verification techniques. So that's why we say that test, inspection, and testing are not opposing themselves. They are actually complementary. That means that you can use both to achieve a very good result. Okay, so that is that. So how do we test? To test, you have to follow a plan or a model. So the model of software testing process. First, you need to design the test cases. The test cases will be the various scenarios that you want to look at in terms of testing. So you have your test cases, and then you prepare the test data based on the test cases. You prepare test data, then you have your test data. Now you use the test data to run the program, and then you have your results. Now you're going to compare the results with the test cases, and then you prepare your report. So basically, that is how then is done. You start with a design of the test cases, then you prepare the test data, you use the test data to run the test, you have your results, compare the results with the test cases, and you have your reports. Okay, so now let's delve into testing, the stages of testing. Now, before I start, I need to clarify something here. When we talk about stages of testing, it's not the same as types of testing. Okay, there are different types of testing. Not the same as stages of testing. Here we're only looking at the various phases where you can actually, the various phases of the development life cycle where you can actually test this. That is all we refer to as stages of testing. But if you take every stage, there are different types of tests that you can perform. Okay, so as we start discussing them, we'll see some of the types of testing that are done at the various stages. So the first stage we want to look at is what we call development testing. Development testing is done by the team developing the system. Whilst they are developing the system, they perform some types of tests in order to discover bugs and defects in the work that they are doing. Then we also have release testing, which is a stage of testing. Release testing is different from, it's a separate testing and is done by a separate testing team. And to do that, you need to have a complete version of the system. And they test it for validation. We'll get this. So I'll explain that, what I mean by they test it for validation. And we'll see the difference between release testing and then development testing. Then the last stage is what we call user testing. Here, a user or a potential user of the system will be allowed to test the system in their own environment. And again, there are different types of user testing that we'll be looking at. So we're going to take them one by one and try to understand what we mean by development testing, release testing, and user testing. So I'll start with development. With me. Hello.
Oh, hello, sir.
Oh,
Yeah. Okay, all right. So we want to start with development testing. Now, what do we mean by development testing? As I explained earlier, this is done by the team building the system. They perform development testing, and there are different types of tests that they perform. The first one is unit testing, and they also have component testing and system testing. Now, for us to understand what we mean by unit testing, component testing, and system testing, I need to explain something here. What we call hierarchical approach to system development or modular approach to system development. Now, in using modular approach to system development, you can have a complete system like this. This is the system you want to build. Okay. But it's not easy. Just start building a complex system as a whole like this. Normally, you want to break it into smaller units. Okay. So you have, let's say we can have it divided into this 4 parts. So we can call these 4 parts as the components. Okay, so these are the 4 components making the system. Now, if we take each component, let's say we are looking at this component 1, this component 2, and we have component 4 here. If you take each component, you can actually break it down to what we have units. So smaller units. So let's say we have 4 other units. So unit 1, this will be unit 1, and this will be unit 3 and unit 4. Okay, so each unit now, so we can break this one into various units. Okay, now you develop at the unit. Call it module. Module is a functional unit. Now, once you develop these modules, which are units, you now test them in additions and ensure that each is working fine. Once they are all working fine, they are meeting the requirements, there are no defects, or you have tested and debugged and you are sure that everything is fine, then you go ahead to integrate them according to the plan you have, integration plan. You integrate them to get the components. So if we integrate all of this, okay, if we integrate one, we add this to this, then we add this to that, and then later add this to this, then we have a complete component. So this will give us the components, okay? Now, once you integrate to get a component, you have to test the components as a whole and be sure that the component is also working fine. Now, if you integrate the units and you get a component, you need to test the component as a whole, as I said. But the focus of the test is going to change. The kind of test you perform at the unit level will not be the same test you perform at the component level. So at the unit level, you'll be looking for defects in the various units. For example, the methods, the parameters, and all those things that are used in the units will be tested. Okay. So once you are done with that, you come to the component, you integrate to get a component. Now you assume that the units are working fine. So you are going to shift your attention to testing the interfaces between the various components, the various units within the component. You test the interfaces between them, among them. Okay, so once you are done with the component testing, you now do that for all the components that are going to be in the system. And then once the components are fine, you integrate them to get a system like this. And as you get a system, you have to test the system again. That's why we have system testing. Okay, so the system testing has to do with testing the whole system after you've integrated the various components to get a system. So what do you look out for when you are testing the system? We know that as you integrate the various components to get a system, these components now will be interacting among themselves in the system. So when it comes to testing the system, you need to test the interactions among the components within the system. So that is what you do when you're looking at, you are performing system testing. So now we can continue and look at unit testing, component testing, and system testing as subtopics. So I've explained what unit testing is about, what component and system testing is about. So if we continue, we want to look at unit testing. Unit testing is a process of testing individual components in isolation, as I've already explained. It's a defect testing process. That is to say that when you are performing unit testing, you are actually looking for defects, errors in the system. So you choose your data that will allow you to expose the defects in the system, in the unit. Okay, so you choose your test data that will help you expose or discover the defects in the unit. So unit may be individual functions or methods within an object. It could be object classes with several attributes and methods, or it could be composite components with defined interfaces that are used to assess their functionality. So example is object class testing. If you're going to test the object class, how do you perform the test? We all know what objects are, I guess. Do we know what objects are? If we're looking at object-oriented system development, we consider everything to be an object. And if you have a group of objects that have similar characteristics, then you can put them together to have what we call a class. Okay, so a class will have many objects. So if you have a class, you can instantiate it, or you can create an instance of a class, and that will be the objects. All right. So when we're testing, we want to look at the various objects. So you have to create a test operations that are in the class, and you set and interrogate all the object attributes, and then you exercise the objects in the various states or possible states. So what do we mean by states? Now the states define the values of the attributes of a particular object. So for example, if you have an object called a car, now this car will have engine type, it will have specific values for all the attributes that are supposed to be a car must have. Okay, so once you are able to specify those values for a particular car, then those values will now define the state of that object, which is a class, a car, we describe it. So that is what we mean by the states. So in testing the class, you need to create all the various objects, test them for the attributes, and exercise them in the various possible states. Now, inheritance makes it more difficult to design object class test. Why? Because the information that is, okay, let me explain it this way. The objects and the methods that are supposed to be tested are not localized in the subclasses. They are rather placed in the superclass. So let me explain that. In an object-oriented approach to system development, we have what we call inheritance. And inheritance basically means that there is a superclass, and this superclass has methods, and attributes. The attributes we all know, if you are writing a code, will be the variables. Okay. Now, these attributes and operations, which we call methods, will be inherited by subclasses. So we can have as many subclasses, and these subclasses will inherit from the superclass. The idea of inheritance comes from, let's say, a family. If your grandfather has something, your parents inherit it, and then you can also inherit from your parents. So that means that as a grandson or a granddaughter, you can inherit from your grandfather. So that is the same concept we are using here. We say that the subclasses can inherit from the parent class, which is the superclass. Okay. So we're saying that assuming you want to test this subclass, you need to test the methods and then the attributes in this subclass. However, we know that because of inheritance, some of the methods and attributes are not localized in this subclass. They are rather placed in the superclass for them to inherit. Therefore, if you are writing your test, class test, what I'm trying to say here, that if you are going to design your test cases to test this particular subclass, it becomes difficult because the methods and the attributes that you are supposed to test are not found here, but are rather in the superclass. So that is what we are trying to say using this statement here, that inheritance makes it more difficult to design object class tests. Why? Because the information to be tested is not localized. In other words, the information is not in this subclass here, it's rather in the superclass. I hope I've explained this concept very well. Okay, so we can continue. Now, so this is how a class looks like. A class, you have a compartment for name. So this is the class name, weather station, and this is where the attributes are. And then we have a place for the operations. So all these things you are seeing at the bottom here are the operations. Operations are the same as methods. Okay, so you have to test the attribute and test the operations. So this case has been written, test case has been written for testing the class. We're not going to focus on this. You guys can go through and have understanding of what it means. So let's move to discuss a different thing, automated tests. Now, in system development, any test that is performed repeatedly can be automated. Okay, any test that is performed repeatedly can be automated. For example, unit testing is done repeatedly because you have to do it on all the units. Then we also have regression testing. We'll discuss that later. We have regression testing, and we also have, okay, so let me limit to that because we are here to discuss this one. So because unit testing is done repeatedly, and that you need to have a framework. So there's a framework called JUnits. Okay, so JUnits is a framework, a test case in order to test to perform the unit. So automated test complaints. So that is that. You can read that about that. Let's continue. So for the day, and then we'll call so because time is up. Now, how do we choose the test cases if you have to form a unit test? Remember at the beginning of this discussion, talking about testing, I mentioned that there are two goals for testing a system. One, you want to show that the system is doing what it's supposed to do. The second is you want to find defects or errors in the system. That means that we have to choose different types of test cases for validation testing, the second one for defect testing. Okay, so this slide actually explains that. So it's saying that the test cases should show that when it's used, it's used as expected. The component that you are testing does what it's supposed to do. So that is for validation testing. And the second part says that if there are defects in the component, this should be revealed by the test cases. So we're looking at defect testing. So what do? We have to choose two types of unit test cases. Okay, one for validation testing and the other for defect testing. So that is that. God willing, next week we'll meet online. Okay. Any question or comments?
Yes, sir.
Okay.
Please, the slides, how are we getting it?
Yeah. Actually, to upload them on the elements for you to
Okay.
access. So what I'll do is
Okay.
that today I'm going to upload all the slides. As I told your class rep earlier today, I'm going to upload all of them, and then you can have all and start reading ahead. I'll also add other materials that are related to what we are discussing, so you can have access to them.
Okay, sir.
I know I've delayed I've not uploaded them yet, so you guys are struggling, but I promise you get it this weekend, so you can start reading.
Thank you.
Yeah. Any other question or comments?
No, sir.
Okay, then enjoy the rest of the weekend.
You too.
Goodbye.
Bye-bye.
Yɛbɛgu so atwa mbisa madamfo bi ɔsɛ ɛyɛ na ayɛ saa nti gye sɛ ɛgu so try saa kyerɛ akora na matry adwuma ahwɛ obi afrɛ o
Steven, with your microphone, why?
menim number ɛyɛ bɛrima.
Steven,
Okay. Thank you.
Hello. Good afternoon.
Good afternoon, sir.